I was sitting in class, and this was over 13 years ago, and I had a professor who was like, well, everybody knows that advanced glycation end products are the reason we're all old and aging. And I was like, what? I almost fell out of my chair, and he never said anything after that. And then for 2 weeks, I couldn't sleep, and I was like digging through PubMed, reading pretty much every study on it, found out that the man who was like leading the research in this field was literally across the way in Manhattan at Mount Sinai School of Medicine. And so I like hopped on the subway and the bus or whatever and got to his place and like begged him to be part of my PhD committee. And he ended up joining and has become like a really amazing mentor to me. But in that moment when I was researching on PubMed, it was so obvious to me that it was soup. Like, how come no one's talking about soup? Like, it's obviously like the answer to, what the best way to cook is when it comes to producing the lowest amount of AGEs. Because all of these studies at the time were saying, like we need to avoid high heat cooking, and cooking with water is good. And like they kept skirting around the issue. But because I had grown up in a Vietnamese household where like broth is life, and we talked about this earlier about how like it's so integral to so many different aspects of our culture that it was like a no-brainer to me. Like when there's a wedding, we have a soup. And when you're sick, there's a soup. And when you have a child, there's a soup. There's like literally a broth for every occasion.
There's functional soups, it seems like. It's
functional soups. Yeah. It's a way of living. And so I feel like for me, it was like so obvious. And it took me 13 years to finally share that.
Wow, that's so cool. I'm not exactly sure what an AGE is. And an AGE, was that like, who invented that? Because it's like age, and
I don't know who came up with that term, but it's quite brilliant.
Yeah. But yeah, can you explain to us what an AGE is?
An AGE is an umbrella term for the hundreds of compounds that form when a reducing sugar, so that's either like glucose or fructose, attaches to a lipid from fat, amino acid from protein, or nucleic acid from DNA. And then it goes through like a series of reactions and finally forms something really stable called an advanced glycation end product, or AGE. And these AGEs, there's so much evidence to support now that they are a primary driver of aging and age-related diseases. Like there's such a long list of things. And if you were to basically pull a researcher from any medical specialty, they will confirm like, yes, AGEs are something that we're researching in our field. Like the dermatologists are really into it because it's driving skin aging and skin wrinkling. And then you have the cardiologists who have been researching it because, it's driving heart disease and atherosclerosis. And neurologists are interested because of Alzheimer's. And it's like everything in between, because now we're finally talking about like one of the molecular drivers of aging, and it manifests as all these chronic diseases and multi-organs and like multi-system diseases. So to me, it's super interesting because at the end of the day, it's like one of the best ways to mitigate, the damage from AGEs or to prevent it is with soup. And I find that hilarious. So
the soup lady.
The soup lady.
You are the soup lady.
Yeah. But yeah, it's cool to be able to talk about something that finally I feel like is coming to light after all these years.
That sounds like it's so upstream from a lot of these health issues.
Yeah.
And does this have anything related to diabetes and blood sugar, high blood sugar?
For sure. So to give you a backstory, in the 1980s, we kind of thought of aging as different silos. So there was diabetes, and then there was Alzheimer's, and they were considered like pretty separate things. Until in the 1980s, someone said, wait, I think there's like a metabolic connection between Alzheimer's and diabetes because there are so many, I guess, metabolic commonalities, right? So if you have insulin resistance or you have diabetes and it's untreated, later on you can develop cognitive decline that very much looks like Alzheimer's. So much that they called Alzheimer's type 3 diabetes. And then in the early 2000s, there was a recognition that it was the commonality was advanced glycation end products. So this whole field is rooted in the study of aging, which originally started as two different silos, but finally was kind of found out to be related. So your question about diabetes, there's actually two types of AGEs. There's endogenous AGEs, which we can actually create in our own bodies. It's a totally natural thing. From the moment we're born and we start aging, we can start to accumulate our own advanced glycation end products that we create in our own bodies just from the same reaction, totally natural process. Then there's exogenous AGEs, which are the ones that are formed through cooking, like I mentioned. You can also get them from your environment. So if you're a smoker, people are obtaining that from cigarette smoke also, or if you live in a high pollution place, sometimes it's in the air. But in diabetes, for people who have really high AGEs in their blood, because they have unregulated blood sugar, they can actually have so many AGEs in their body that it pushes them into diabetic complications. So it's really, if you look at a person with diabetes who has unmanaged diabetes, they seem much older biologically. Like their skin on the exterior will have more signs of aging. Their heart, usually a lot of people with diabetes who don't have, who are not managing it well, will go on to have heart disease. And like I said, there's cognitive decline and Alzheimer's, joint pain and arthritis. It runs the whole gamut because, again, upstream, if you're looking at the molecular commonality, it's these advanced glycation end products.
Wow. And it seems like this should be the primary area of focus, because if we can reduce our AGE consumption, and like, even if there's ways to reduce like the creation of these endogenous AGEs, like that would naturally prevent, at least limit some of the development of all these other diseases.
Oh, for sure. Yeah.
Wow.
And that was a lot of the interest behind, like, you want to have good blood sugar. I think finally people are ready for the conversation on AGEs because of the work that was done by people who are promoting, like things about blood sugar and having healthy blood glucose. But it's all on the same. It's all the same thing. It's all related. Yeah, because we could talk about blood sugar, but then what we're talking about now is like what happens if you have really bad blood sugar, right? Like if you have really bad blood sugar, then you're kind of increasing your chances of having more AGEs in your body, and then that's how you can kind of increase your risk of all these other diseases.